Hey everyone and welcome to Java tutorial for beginners, the only resource you need to learn Java from scratch with no programming experience required. This tutorial has 5 parts that you can find in the Java programming playlist, and in this third video we're going to learn about logical operators, conditional statements like the if and switch statement, and most importantly we're going to learn about while and for loops. So without further ado, hit the like button and let's jump into it. Alright, so in this lecture, we're going to learn about logical operators in Java. So for that, we're going to learn about a really important primitive data type that we have in Java, which is called Boolean. We haven't covered this type on the primitive types lecture because it's really more relevant in this particular context. So the Boolean data type actually works in the same way as the other data types. We can declare variables in exactly the same way. The only difference is the actual values that it can store. And it's actually very simple one because it can store only two values. It can be either true or false. And those particular values that you can see here are actually keywords in Java. So you cannot use them to define variables or things like that because it will basically crash with some error. So you can see them just like some constants, some Boolean constants actually, that are used to initialize Boolean variables. Now, in this particular case, this is a very simple initialization, right? But in Java, we can also do things which are a little bit more complex. For example, if we have, let's say, an integer variable, which is called simply I, we can initialize the value of this particular Boolean variable with something like that. So we can say I is greater than 0, and the value of this comparison or the value on this evaluation is going to be true or false, right? In this case, it's going to be false because I is equal to 0, right? It's not greater than 0. So when the execution will be finalized, the value which will be stored in this Boolean variable will be false. And let's actually see this in action, right? So as you can see, the value is false. So what happens here is that this operation is evaluated to true or false. We refer to this as a conditional statement or operation because it depends on some kind of logic that needs to be evaluated by the program. We also have other operators, for example, less than or equal, greater than or equal. We also have things like not equal to. So if we have the value of I equals to 2 and we want to initialize this Boolean variable this way, right? This operation here will evaluate to true because I is different than 0, right? This operator here is basically not equal. So I is not equal to 0, right? Because it has the value 2, so it will be evaluated to true, right? So as you can see here, this is exactly what happens. Now we can also have scenarios which are a little bit more complex. For example, if we have two variables, let's say I and j, we can have something like that. I is different than 0, and we can also combine the result of this operation with another one. For example, I is different than 0 and j is different than 0, okay? This particular operation here, this double ampersand basically, is called the Boolean AND operator. And how it works is that it takes two conditions at the left and on the right of it, right? So it has basically two operands. And if both of them evaluate to true, it will basically evaluate the whole condition to true, right? And if at least one of the conditions is false, then the entire result of the operation will be false. In this particular case, it will evaluate to true, right? And let's actually see this. If we run the code, right? As you can see, the value is true. But if we make j 0 and we're going to run this, we can see that it is false, right? So this is a way to combine multiple conditions together. We also have another operator here, which is called OR, right? Or logical or Boolean OR. It can be found on the internet or using multiple names. And this works in a very different way. It also takes two conditions and it evaluates to true if at least one of those conditions is true, right? And it will evaluate to false if both of them are false. So in this particular case, if you run the program, we're going to see that the value which is evaluated is going to be true, right? And it will resolve to false if only both variables are equal to 0. So as you can see, the value is false. Now we use this not equal operator. We also have a different operator for equality, which is basically double equal. If we use this operator, it will evaluate to true if the value of I is equal to 0, right? So this is the actual equality operator. It's very important to not mix this operator with the assignment operator, right? That we just talked about previously, because this one, what it does is to take the value at the right of it and place it into the variable on the left of it, right? So for comparison, we need to use double equal as the operator. As you can see, also IntelliJ IDEA is helping us to highlight the fact that the result of this assignment operation is an integer and not a boolean. So this is very, very important and you should really keep that in mind. And also you may wonder why IntelliJ IDEA is highlighting us this. And the reason is that we're using constants in this particular program because we want to just highlight the functionality, right? And we just initialize this with 0 and we're also comparing against a constant. And for that reason, IntelliJ IDEA already knows that this condition is evaluates to true or false depending on what values we are using here. But in real world, you can imagine that those are not constants. Those are user inputs or values which are dynamically generated by the application and things like that, right? So in real world applications, this particular warning will not be highlighted by the IDE. So I really recommend you to experiment with those Boolean values by just using this example or any other similar one to just kind of get an idea on how they actually work, because they're really important and they are the core functionality of the control flow instructions in Java and in pretty much any programming language, right? Because without conditions, we're not going to be able to decide on which flow the application should go, right? All right, so now that we know how the logical operator actually works, we're going to start learning about the first conditional statement that we have in Java, which is actually the simplest one, and it's actually called the if statement. So what this instruction actually does is to test a condition and execute some instructions if the condition is true, and execute other instructions if the condition is false. It allows the programmer to define two execution flows depending on some condition. And that's what we're going to exercise now. So the syntax is the following. We have if followed by space and then followed by parentheses, where we're going to add our condition. And then we're going to open a bracket. And we're going to also close a bracket with the role of defining a scope for this particular if statement. And inside this scope, we're going to define instructions that will be executed if the condition is true. And if the condition is not true, then the control or the execution will simply jump those instructions inside this particular scope. So first of all, let's take an example of a condition, right? To just get an idea on how it works. So let's just play with integers as we did in previous lecture. So we can just say if I is greater than 0. We can just print something out if this is the case. Let's say the value of I is positive, right? We're going to adjust the value of I to actually see how it works. And right after this if statement, we're going to say the scope of the if statement is finished, right? So what this means is that we just passed out of this if statement, right? So if we run the program now, or actually let's make that I positive, right? In order to see that this instruction is actually executed. So if we run the code now, we're going to see two prints, right? Both of them actually. The first one tells us that the value of I is positive. This instruction has been executed successfully. because the value of I is 2, which is greater than 0. So this condition evaluates to true, which means that this instruction inside the scope of the if statement will be executed. And then after the scope of the if statement has been executed, this instruction, which is right after it, will be executed as well. Okay? So that's a very simple and intuitive way of understanding how the program actually works. But now if you make the I equals to 0 or even a negative number and we run the program, we're going to see that only the second print line is executed because the first one is inside the if scope and the condition has been evaluated to false, right? Because -2 is not greater than 0. So the instructions inside the scope will not be executed, okay? So this is a very simple way of kind of understanding how the if statement works. And now I'm going to talk about some variations of this statement, which can be useful in different contexts. For example, you may want to execute something if this condition is actually false, right? No matter what the condition actually is. If it is false, you want to execute something else, right? And potentially you want to execute something else right after the if statement, which is not related to it in any way. And for that reason, we have the else keyword that we can use, that we can actually attach to an if clause. And what this will do is to allow us to define a scope that will be executed if the condition is false. So in this particular case, we can say that the value of I is negative. And this particular instruction will be executed when the condition is false, right? So it's a very simple one. This is a very nice way of kind of explicitly saying what the program should do on any value of this particular condition, right? So as you can see, the execution actually entered on this else branch, and then it also continued with the last print line as we actually expect. Now, a very commonly used form of the if statement is when you have multiple values or multiple conditions that you want to test, right? For example, if you have the value of I, let's say it is 0, and you want to do something different for multiple values of I, you can use the following form of the if statement. So you have the first condition, which will do something on the first branch. And let's say you want to do something else if the value of I is 1. And for that, you can use this instruction. So you can say else if, right in this way. And then you add a different condition. And then you add a new scope with all the instructions that you want, right? And you can continue this for any values that you want to test, right? You can imagine that instead of those particular values, you can have different conditions, right? Which may usually be related to each other, but depending on the context, they can be pretty much anything. So depending on the value of I, it will basically go on a specific branch. Of course, this print is not relevant in this case, but you got the idea. And also if none of those values are matched for this value of I, you can also have a final else statement without any if. And on this final else branch, you're going to execute some default instructions, right? So there is a scope that will be executed if the value of I is not equal to any of those ones that are just defined right above it, right? And as you can imagine, the first condition that will be matched will actually be executed, right? And then the execution will actually move past this if else block. So it will not go one after the other. This is very important. So let's say we have the value 2. If we have the value 2 here, this condition will be evaluated to false. It will then try to evaluate this condition, which will also be evaluated to false. It will go here. This will be evaluated to true. It will execute this, and then it will move out right here. Okay, so that will be the behavior. Let's also update this to make it a little bit more understandable, right? So if you run this program now, I'm going to use the shortcut, right? So as you can see, the value of I is 2. So it went right here. and then it printed out that the scope of the if statement is finished, right? So we just reached the end of the program. So basically, this is how the if statement works. It's a very simplistic and a very effective, actually, way of defining control flows in your application by simply defining two branches, right? And now we're going to move to a more advanced version of the if else statement. All right, so in the previous lecture, we discussed about the if statement, and we saw that we can basically create a cascade or a chain of conditions using this else if construction that basically allows us to define multiple scopes that can be executed when certain conditions are evaluated to true, right? Now, in Java, we also have an advanced version of this particular construction, specifically when we have only values involved in conditions. And this instruction or this statement actually is called switch. And we're going to take a look on that as well. So the switch statement has the following syntax. So first of all, we need to say switch. And here we need to add a variable. In this case, the variable I to kind of have the parity with the existing example. And we now open a scope. Now inside this scope, we have a different syntax for handling each case. And this syntax is very, very simple. So we just have to say the keyword case, followed by the value that we want to have, for example, 0. And then we can open a new scope, which will basically contain the instructions. So what this means is that when the value of I is equal to 0, then the instructions in this particular scope will be executed. And similarly, we can have different cases for different values of this particular variable. If no case is being matched, then for that reason, we got the default keyword, which will basically allow us to define a scope that will execute when there is no match for that particular variable, right? So this is a very clean way of basically handling different cases when we got multiple potential values for a particular variable. There are a couple of things that we should know about the switch statement. So it's a really great construction when we have like a variable with multiple values that we need to account for. I'm going to comment out this particular piece of code here that we already saw how it works. So let's say we have the value 0 for I, right? If we run this code now, we should technically see that the first print is executed, right? The first instruction here on the case 0. But as you can see here, in a very strange way, it says that the value of I is 0, but it also prints out the other instructions on the other cases as well, right? And we don't really want to have this. Because what happens is that when the match is being done on one of those cases, then all the instructions on the downstream cases are also executed. For example, if we have here the value of I equals 1, and we run the code again, we shouldn't see this print line with 0, right? Because it matches this one, right? Because the value of I is 1, but it also goes down here. And this is a behavior that usually we don't want because it's not necessarily so useful in most of the contexts. And for that reason, we need to add a very important instruction at the end of each case, actually. And this instruction is break. So when we add this instruction, what happens is that when a particular case is being matched, all the instructions in its scope are executed, and then the evaluation of that particular switch statement actually breaks. So the control is basically moved out from this case after all the instruction that it has defined are executed, and then it will jump directly on the next instruction after the switch statement. So it will not make that cascading effect that we just previously saw. So the fix here is just add the break instruction on each case. So now if we run the code again with the value of I equals to 1, I just hit debug my mistake, but it should be fine. We're going to see that only this print is basically executed. And this is exactly what happens here. You can ignore the prints related to the debugger. So this is a very important aspect when working with the switch statement. To not forget to add a break instruction to make sure that you close the evaluation loop of the switch statement when a case is being matched. So this is very, very important. And also this is not required for the default case, because if you have the break instruction on all the cases, it will execute the default case when no case has been matched, right? So this is the main behavior of this case. So there are no more cases after the default one, right? So you don't have, so it's not necessarily required to add a break instruction here as well. Now, the second observation that I want to make around this switch instruction is that, first of all, we should use it when we have simple variables that we need to check against values, but we can't really use it when we want to have some more complex scenarios. For example, right here, we have the value I. We can't really have here a condition or something like that the value is to true or false. So we can say switch I is greater than 0 and have a case that says true or false. What we actually need to do is to replace this with an if statement. Yeah, so as you can see, the switch statement doesn't accept a Boolean type, right? It only knows to deal with value types or even reference types, but not with Boolean values. So this is an important thing that you should keep in mind. And also, if you have, for example, something like this, if you have a string or, let's say if you have a string and you want to switch this name, let's say you have, you want to do different things if that name starts with with a specific string. So you want to do something like that. If name dot starts with something, right? You want to add some instruction, and then if name starts with other thing, Daniel, something like that, you want to do other thing, right? So you kind of got the idea here. Now, the switch statement doesn't allow us to do this, right? It's not supported here. So the case instruction should only be used with absolute values, right? So with strings directly. So it only allows us to see case Daniel, right? So real values here. And it works pretty well in this way, right? So that's the case where the switch statement actually brings the most value. So that's pretty much all about the conditional statements. They are really useful, and they're actually the meat of the control flow instructions. Now we're going to learn about iterative control flow instructions. Alright, so now we're going to learn about iterative instructions, which are basically constructions built into the language that allow us to execute certain instructions up until a specific condition no longer evaluates to true. That's the main idea of the iterative or repetitive instructions. So we're going to start with a very simple iterative instruction that we have in Java and also in other languages as well, which is called while. So while has this very simple syntax. So we start with this reserved keyword, and then inside the parentheses, we need to add a condition. And that condition should basically evaluate to true or false. Let's say we have a very simple example as well, with a very simple integer value, which is currently initialized with 10. And then here we're going to add the following condition. So we're going to say while I is greater than 0, and then we need to open a scope where we're going to add our instructions. And let's say we want to print out the value of I is I, and then what we're going to do is that we're going to decrement the value of I. And I'm going to say this explicitly. So basically what happens here in this instruction is that while the value of I is greater than 0, those two instructions will be executed one after the other. So initially, the value of I will be 10. So we're going to see in this print the value 10, and then it will decrement by 1. So it will become 9, right? So the value inside the variable I will become 9 after this instruction gets executed. And then the control will basically go back to this condition. It will evaluate it, and it will say whether 9 is greater than 0. which is again true. So those instructions will be executed again. And this continuously happens until the value of I becomes 0. So when the value of I becomes 0, it will go back here and it will check whether 0 is greater than 0, which is definitely false. So it will exit from that while loop. That's actually how those instructions actually are called, or that's how programmers actually refer to them: while loops or for loops or simply loops, right? Which are basically repetitive instructions. So we can see here that the while has ended, right? So let's run this to see how it actually works. We should basically see the exact output that I previously mentioned, right? So as you can see here, the first print is the value of I is 10, and then it progressively goes down to 1, and after this one value is actually printed, the value of I becomes 0. So when it's going to get back here on the condition, as I previously mentioned, it will check whether 0 is greater than 0, so it will exit the while loop. So this is a very, very simple and very effective repetitive or iterative instruction. Now, a really important thing about loops in general is that we need to make sure that they will terminate eventually. Because if this doesn't happen, the while loop will continuously execute and the program will basically get stuck. This doesn't actually happen with the conditional statements because they are always evaluated to either true or false. So the program always has an ending if we only use conditional instructions. But with repetitive ones, we're basically locking out the execution inside this particular scope. And the program will only exit if it manages to get out of this loop, right? So we can have a what's called infinite loop, which is basically a scenario where the condition of this loop will never get false. So it's always true. For example, if we remove this instruction here, right? So we have the value of I10 and we're not decrementing it, or we're not altering it in any way to make it reach a value that will make this condition false. This particular while loop will run forever. And if we run the program now, we're going to see this in action, right? So as you can see, it continuously prints the value of I is 10. And as you can see, this scroll down, this scroll actually gets updated because the program is not finished, right? So it continuously does this print operation, right? So I'm going to stop it forcefully by hitting this red button. And this is very, very important, right, for you to know. There are also other ways to exit from a loop other than ensuring that this condition gets evaluated to false. And this actually involves the break instruction that we just saw previously when we discussed about the switch statement. So we can say something like this: if the value of I is equal to 5 or any value that we want, we can say break, right? And we want to decrement that value as well here. That's of course a very different example where I'm trying to highlight that we basically want to decrement the value of I, and when that value reaches the value 5, we want to break the loop. So we want to exit from that while statement. So it will not wait until the value of I becomes 0. It will exit from this while statement when the value of I is equal to 5. Okay? So if we run this program now, yeah, we're going to see that the last value which has been printed is the value 6. Okay? So we did exactly what I just previously mentioned. So that's the main idea with the while statement. It's a very, very simple instruction that we can use to build iterative flows. We also have a variation of this instruction that allow us to execute some instructions before the condition of the while statement is evaluated. So I'm going to comment out this particular section right here. So this variation of the while statement is called do while. And what it does is that it allows us to define the scope that will be executed in an iterative way or repetitive way before the condition is evaluated in the first place. So if we have to make this equivalence here, we need to add the condition at the bottom of the chain of instructions that are executed inside this loop. So what this basically means is that we define the scope, we execute the instructions, and then we evaluate the condition. So what this means is that the instructions are executed at least once until the condition is evaluated, right? So this is definitely different from the way we saw in the original while instruction, where the condition is evaluated at the beginning, right? So in this case, if we have the value of I equals to 0, it will not even enter into this while statement because the condition is first evaluated, and if it's false, then the whole while block will be avoided, right? So it will be completely ignored. In the case of the do while statement, if we have the value of I equals to 0, those instructions here will still be executed at least once, right? Actually, exactly once in that particular case. And then the condition will be evaluated, it will be false, and then it will move on to execute the next instructions, right? So let's actually see this in action, right? So we're going to say this to kind of make it similar with the previous example. So we have the value of I initially equals to 10, and we want to see what this program prints, right? So it will go back to 10. In this case, we're going to also see the value of 1. Yeah, so the print is definitely identical. But if we change the value of I to be equal to 0, what we're going to see is that the value will still be printed here, okay? As you can see, it printed out the value, it decremented the value of I, so it became -1, and the while loop has been completely terminated. An important difference between the do while statement and the while statement is that in the do while statement, we have this semicolon after the while condition. In the classical while statement, we don't have this semicolon here, right? So we don't have this one here. And that's a really important thing to note. Also, the compiler, I think it warns you, right, if you're not putting it. That's just for the sake of, seeing the differences between those very similar instructions. And of course, as you can see, this is useful when you have some kind of scenarios, of course, that involve some iterative process where you want to execute some instructions first and then decide based on the outcome of those instructions. That's where the do while statement can be used properly. So now we're going to learn about the for statement. All right, so now we're going to learn about a very commonly used iterative instruction, which is a little bit more complex than the while loop. And this one is actually called the for statement. And the syntax for the for statement is the following. So we have to say for followed by parentheses. And inside those parentheses, we have actually 3 main sections that we need to add. The first section is called the initialization step. And here we basically need to declare a variable I equals to 0. And I'm going to delete this to avoid the conflict. The second section is basically related to a condition that we need to add here. Let's say I is smaller than 100. And the last one is an update step, which basically should refer to this variable here that we just declared. So in this case, we're going to make I++, which basically increments the value of the variable I. This is a very commonly used construction, which basically iterates 100 times and executes the instructions that we add here inside those brackets. So we can read this instruction in this way. For this variable, as long as it's less than 100, we're going to execute those instructions. And of course, we need to update the value of this variable in order to make sure that it reaches this value. And this basically connects to the observation that we made on when we talked about the while statement, which is the fact that we need to ensure that the while loop should eventually end at some point, right? So this is something that we as programmers need to carefully think of. And if we run this code, we can see that it prints out the value of I 100 times, right? Starts with 0 and goes up to 99. So first of all, if we take a look on the structure of this for statement, we can see those three main sections which involve this variable I. But what actually is the role of this variable? The role of this variable is to basically act as a counter or as a value that tells us at which iteration we are in this particular for loop, right? So depending on the logic that we have in the program, by checking this value of this counter, we're able to tell when we are at the middle of the loop or at the end of the loop or in any place in the loop actually. So for example, if we want to stop for some reason this iterative instruction when it reaches the middle of the loop, we can just say if I equals to 50 or any other value, we want to break this, right? So we want to close the loop when this value is at the middle of the loop. That's the main role of this counter. A very important thing to note is that this variable I, or any name that we can place here, can only be accessed or modified inside the scope of this for statement. So we cannot have any access to the I variable right after the for statement has been closed, right? So as you can see here, it says that the variable I is not declared because it's outside of the scope of the for statement. And this is very important, right? Of course, you're not forced to declare the variable here inside the for loop. You can basically declare it outside of it, and you can use it here as any other variable. And in this way, you're going to have access to it outside the for loop because you declared it outside of the for loop. But of course, you need to make sure that the variable doesn't get modified in other way when it's being used inside this for loop. And as you can imagine, we can do the same thing using the while statement by using this variable declared outside of the while scope. So we can say something like while I is less than 100, we want to do something and then increment the variable in the same way we're doing here with the for loop. The difference is that the while loop has not been, let's say, designed for this use case simply because it's a little bit more generic. So you can make the things equivalent using both constructions, but the for loop is more suited for those kinds of scenarios where you actually need this counter to see the point in the iteration where you are currently at. And this is very convenient. If you're trying to use it a couple of times, you can see that it really gives you that sense of safety when you are able to check the iteration number, basically. Now, really interesting is that the for statement is even more flexible than that. So we can have a for loop which looks like that. And it's very weird, right, if you take a look at it. But what this actually means is basically an infinite loop. So we are not specifying here any initialization step or condition step or even update step. So this is basically the empty instruction or the void instruction that doesn't do anything, basically. So if we have to print this and we comment this out and we run the program, we're going to see that actually we have an error here, as you can see. So we're not able to run the code because of that. I just deleted that line and we're going to run it again. And as you can see, it prints that in iteration continuously, and we have to stop the application forcefully. So this is basically a way of playing with the for loop. Of course, you can use the break instruction to stop this loop whenever you need. But that's definitely just another way of playing with the for loop, right? Just for the sake of seeing other ways of playing with it. And also we can have like multiple instructions that we can use to initialize it. For example, if we want to use two variables here, we can declare them in this way. Let's say we want to work with I and j. So we can say something like I plus j is less than 100. And then we want to increment I, but also increment j. Okay. So what this does is basically to take those two variables, initialize them with 0, and then on each step, both of them will be incremented. So this basically will stop when their sum is equal or greater than 100. And this, of course, will happen when I, for example, if is 50 and j is 50 as well, right? And their sum is 100, which is not less than 100. So we can just print them here, something like that. And when we run this, we should see their last values. Yeah, actually, I was a little bit wrong here. Yep, the value should be 49 and 49 because when they are incremented, they will reach the value 50, and only then the condition will be evaluated. So this is very, very important. And also you can add different instructions for updating those values. For example, you can use different steps here. Instead of incrementing by 1, you can increment by 2 or by any other number that you want, j plus 2. And as I previously mentioned, you're not required to do this, but it's a more convenient way of playing with the for loop because it was designed to be used in this way, right? So as you can see, we have here a different step, right? It starts with 0 and then it goes up using increments of 2. So this is another way of using the for loop. You can also add in this scope any combination of conditional or iterative instruction. So you can have here something like a while, and here a for, and here an if, and any kind of combination that you can think of. And so as you can imagine, this can become really, really complex, right? If you just combine those things together in different ways. And you can also achieve different kinds of results or even performance evaluations, right? Depending on the way you combine those instructions to achieve a specific result, right? Because that's the main idea we're using them to get some kinds of results back, whether we're talking about sorting some numbers or searching for something or modifying some data, things like that. So there is no restriction here in terms of which control flow instruction you can use. You can combine them in pretty much any way you can think of. And of course, there are some limitations on the syntax level, but those are not required to the way we combine the control flow instructions between them.